So it is the same convention. All right, we're good. We're good. So we have the exact same calling convention for syscalls as we have. Okay, so all we have to do is we have to move the syscall parameter into v0. So v0 is going to get the syscall ID, and that's going to be v0, or a0, a1, a2. So this is a2. Okay? Okay. Okay, chat. This time for sure. Go. So you have to mark naked functions no return. And then we're moving into v0 from a2. So v0 gets a2 because 0, 1, this is a2. So parameter a2 is the syscall ID, so we pass that in. Okay. All right, this time we're going to actually get this right. Say this lip. Do you need to return in the assembly? Technically not for MIPS. Okay, one argument syscall. Okay, let's do this. Okay, this is A1. Let's make 0 argument syscall. We're just gonna go through the list, make all of them. We cannot use macros to define these, unfortunately. Okay, A0. Then we have a 3 argument syscall. And this is a 3 now. And then 4 argument syscall. And these we don't have to define the args. We'll just say this. ID, this. Extern C is implied by extern. So that's syscall 2. This is syscall 3. 1, 2, 3 use sizes. And then this is A3, so A0, A1, A2, A3. Okay, and then at this point, I now have to start getting that from the stack. So this is a 4 argument syscall. This is 4, blah, use size. But have we met? And then this will be at SP10, or sorry, X10 SP. Load word. Syscall 2 redefined. Okay, I have 2 2s. 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 10 SP. Right? And that should be correct. So, 10 SP should be, yeah, that should be where that is. Okay. This night is sparkling. Don't you let it go. Okay, 1, 2, 3, 4, 5. And then this is now at 14. And we keep going through. We need up to 9 at least. Windows has some really long syscalls, unfortunately, so we're just going to go up to 9. This is now 18. So these ones we actually could macro. We can't macro the register ones, but we can macro the memory access ones. 1, 2, 3, 4, 5, 6, 7. Okay, 8. 8. Blah use size. This is now 20. And then we have a 9 argument syscall. Syscall 9. No, we don't fit. Okay. 24. Load word. Unknown instruction, move. Oh, move with an E. Okay, 36 invalid operand? What? Oh, do I need dollars for all of these? I don't know if I need it for the SPs inside. Okay, we're gonna try it. Hey! Okay. So now we have 000 A0, 111, A1, 222, 333, 444. 4 in this case being 10 SP, 5514, 6618, 771C, 8820, 9924. Okay, that looks correct. So let's see what happens. This should still run and work. Okay, good. We didn't break anything. And now this is definitely correct. Now we know that, unlike before when we were relying on undefined behavior, we know for sure that these are actually correctly running. And yes, the syscall actually returns to LR, and LR is the function. I think this unused thing is changing. I'm gonna do a rust up update. I think naked is supposed to imply allow unused. But I know that this stuff is like really actively being developed right now, so let's see if that's the case. This looks confusing. It's a little confusing. We're writing some assembly right now. Gotta run to the town over. Catch you either in a bit or on the VOD. See you around, Xenoblino. Thanks for stopping by. Okay, we're rebuilding it. And if this doesn't go away, we'll just put allow unused. Oh, interesting. Oh, there's some development changes going on. Oh, wait. Is ASM stable? Is ASM stable now? Is that why it's yelling at me for that? Do I not need ASM? Oh, no, you still need that. Okay. Okay. Allow unused. So we're just gonna put allow unused everywhere. Bam. Okay, that looks good. So now, now everything should be pretty good here. So these take syscalls, move v0 a0 syscall, move v0 a1 syscall, v0 a2 syscall, 333. Everything's no return. And then this way we know that everything is fully controlled. So if we did a make obj dump, you'll be able to see somewhere we should have our, okay, I'm just gonna do this, syscall. So there's syscall exit, and then that's gonna call syscall 2. And syscall 2 is literally what we emit. Now there's a break instruction after, but it actually returns to LR. And since that jumps to LR, these are actually great. These are really nice thunks. So it's just move the syscall ID into the correct syscall ID register, perform the syscall, and then syscall will return back. This will never execute. It will jump back to LR, the caller. And since these are naked functions, they have to be called. So we don't have to worry about these getting inlined. These are explicitly never inline. And so if you factor all that stuff together, everything's good now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6. 4, 5. 4, 3, 2, 1, 0. Okay. Beautiful. Hey, I hope you're having a great stream so far. Hell yeah, I am. Print something after Moose. Well, let's double check. This file looks pretty good now. So we'll say this is MIPS NT syscall conventions. And the convention is ref, very similar to MIPS 032 convention, with interleaved floats and skipped integer registers for when floats are used. Okay. Okay, and then source. What else do we have in source? We have source syscall, and then this is generic syscalls for Windows. Yep, so this handles Windows syscalls, such that we can do Windows Z syscalls here, exit the current process, pubfn, bang, unreachable unchecked. That looks good. Okay. Pubmod MIPS, pub use MIPS star, so that's going to use everything out of there if it's MIPS. Okay, so this just works. This just works. So this looks good. Generic syscalls for Windows, MIPS, exit. That exits with an exit code. This exits the current process. It calls NT terminate process, and then it's unreachable unchecked, which is pretty good. So should we handle exit codes from exit? So NT terminate process. Technically, all NT syscalls, I think, should return NT status. NT status, if it succeeds. Never use assembly personally in my role as a dev. Not that I can remember. Yeah, it's pretty rare unless you're doing pretty low level stuff. Okay, so basically what we've done is we've implemented all of the low-level syscalls. So basically these functions can be used. They're all marked unsafe. They're all marked extern. And basically, these allow me to perform arbitrary syscalls with Windows NT. So basically, I pass in these arguments, and then these arguments go directly to the syscall. So then it's up to me to make safe wrappers that actually do the right things around them. So for example, exit calls NT terminate process. An NT terminate process takes a process handle and an exit status, right? And that's what we do. We pass in a process handle where all Fs is your current process. Code is the code we want to exit the process with, and then we call NT terminate process is the syscall. And then we've made a nice wrapper that's safe that's around that, right? And then we've also annotated this and said that this never returns, which is not necessarily always true. So I think what we want to do, is maybe like a usize here. Actually, I'm gonna do this. Struct NT status U32. These are NT status codes. Okay, so we're gonna strongly type this. We'll also make this pub. And now that we're strongly typing this, we're gonna have a little bit better APIs. Derive. We're gonna give this clone and copy just so it can be moved around pretty cheaply. And then this is an NT status. And then here we'll say syscall to NT status, this as U32. And now that is the result. Okay. Okay, so now start can potentially, we want to make sure start never returns, so we're gonna do a loop after that now. Same with moose, which seems to be our panic handler. So panic handler, syscall exit loop. Okay. And now technically we can get the status code from that exit, right? So if I do a print line of X of syscall exit, oh, and let's add debug. Okay, here we go. So this will give us the NT status code. And exit 0 succeeds. And then let's break this. Let's just have a bad handle here. That is our handle. And there you go. You can see that this failed with invalid parameter, right? Or invalid handle. So now we can actually get error codes from that because technically exit can fail. Exit can fail. And then here we're gonna say, yeah, let's do this. And I think, yeah. I don't like having the loop afterwards, so I think I might put the loop in here. What do you do when the exit fails? That's kind of fair. Yeah, I might do, just for this one. It's really tough to decide this convention because technically you are losing information here. But core, we can just go back to what we had, basically. Unreachable, unchecked. Okay, there we go. We got our moose. Exit the current process with code as the exit status. Okay, so now we can exit with a given exit status. We can perform any syscall up to 9 arguments. All right. All right. That's pretty damn good. That's pretty damn good, chat. All right, IO status block. Okay, so let's start implementing some of these bad boys. Let's start moving these into some good spots. Okay, we're just gonna start stuffing some Windows generic things in here. IO status block, so this is IO status block. Okay. Status code from the command, and then request dependent value about the status. Okay. About the request. And then this is an NT status. So we'll do this again. Pub struct NT status. Pub U32, derive, clone, copy, debug, NT status. Okay. Then information is a usize. This is technically muxed with a pointer. So this is actually a union, which is kind of tough. I think NT status is specifically, I think it is a D word. I think it is a U32. Yeah, it's 32-bit. Okay, NT status, U32, which means that this is technically wrong unless I have this be a union. How do I want to do this? How do I want to do this? I mean, this will get aligned to a U size. So technically this is fine. These will both be U sizes and start. It's fine. It's fine. It's fine. It's fine. Okay. Yeah, default. We can derive default. Okay, so now that we have default for that, IO status block. Nice. Then we can say pub on this, pub on these fields. We're making some nice FFI for Windows. IO status block. Okay, and now we're going to move our write syscall into here as well. Okay. write to a file, pub fn write fd. Let's just figure this out. This is gonna return a NT status code. Egos, thank you so much for the subscription. How's your day going? Hope you're having a wonderful day. Thank you so much for the 2 months of support. Hell yeah. Self.0, that is, that should be a handle. Let's also do that. Pub struct handle usize. Okay, so this is handle. Once again, strongly typing all of these things because that is correct. Strong typing is good typing. Okay, so then this is an fd.0. Okay, and then let's add some comments here just because this is a little gross. Syscall returning, not to the instruction after the syscall is weird. Yeah, it jumps to LR. It jumps to the return, it jumps to the value in the linked register. So since we have naked functions that are not inlineable, LR is actually set to the return for the syscall 8 function itself, which means syscall will directly return out of this. Doesn't make any sense? I agree. We spent like, what, 15 minutes figuring that one out? And being pretty confused? So you have to set LR if you want to do 2 syscalls in a row? Yeah, or you have to use a wrapper function, which is what most people do. Never thought we'd have last kiss. Dude, why is this album so fucking good? T-Swift, man. Like this. Do 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 do. Wish I could hear it. Yeah, I do too, but I think that's one of the ones that's a pretty fast ban. Okay. Which one? This is speak now. Okay, file handle, event optional, so 0. APC routine, 0. APC context, 0. Which are null pointers, basically. IO status block is, mute iOSB. Oh, there's a new thing that I've started to use. Check this out. So this is just a nicer way of kind of writing what I had written there. Right, so that's gonna make it into a raw pointer, which is really, really cool. So I'm a big fan of that. Okay, iOS B, not found in the scope. 53 offset. Oh yeah, those were in here. Okay. It's not working like that. Adarov is a raw address, but I think you can cast raw addresses. Pretty sure. I'm pretty sure raw references I'm pretty sure raw references can be cast directly. Adder of X is, yeah, it's a reference to X, and I want a reference to the IOSB. This is the address of the IOSB, and this should be the address of the offset, right? 62. 50 S not found in the scope. Okay. Bytes is impl asref u8. Yeah, we're using generics now, baby. So now I can do bytes.asref.as pointer. Ah, now we can do strings. Fuck yeah. Bytes.asref.len. How fucking cool is that? NT status. Okay, just wrap that shit as U32 as an NT status. Okay. Okay, let's get some claps in chat. Pub struct result. T is equal to oh, I haven't noticed that IOSB is a value, not a ref. Yeah. Core results T. Well, I'm glad that chat claps on demand. The British rain claps on its own. Okay, and then this will be NT status, and this is attempted a syscall which failed with NT status, which may have failed with NT status. Okay, so now we have like a result wrapper on NT status, and that means that this will actually return a result of usize, and then IO status block information is the number of bytes written. I'm pretty sure information is number of bytes actually written. So then this let status is NT status, or let status is equal to NT status of this syscall. So we perform the syscall, that as U32. Okay, and then we can say if status dot, and how do you tell if something NT success? What's the magic for that? You check like the bottom 3 bits or the top 2 bits. You check I forget what it is. Success. Status success is just 0. We know that, but success. Status wait. Is it greater than or equal to 0? I'm just gonna do this. If status.0 is not equal to 0, error status. Else, okay, IOSB.information. So that will give me the number of bytes read. So if it's 0, we're just gonna be really strict. If success, and we'll do if status success. If success, return number of bytes written. Otherwise, return error. Okay, so then we can impl NT status. NT success evaluates to true if the return value specified by status is a type of 0 to that, or an informational type that to that. So yeah, I guess it is greater than or equal to 0, isn't it? Huh, okay, cool. Pubfn success, bool, returns true if the status was successful. Okay, and then here we're gonna say self.0 as I32. If this is greater than or equal to 0, then it was successful, right? Okay. Type. Okay. So we try a write file, and then we get the result, and then if it is successful, then we return the number of bytes written. So what we should be able to do now is we should now be able to call write. And this is a handle. Okay. And then this will create one. We want the macro to create it. Yeah. Print line, panic handler, print line, boom boop. Writer, which is a handle, this. Okay, 12. Use syscall handle. Where did Moose go? We're not printing right now. We laugh about the vacant stairs, but right now I'm actually gonna say syscall handle. Okay, this is gonna be self.0, which is the handle. And then the bytes, which is S. And that's it. Okay, there we go. Nice. So what we should be able to do is, do we have debug? This love is ours. Okay. I'm just gonna throw this in here right now. I'm just gonna see if this works. And then we won't do ePrint line. No print ln. Do I have to export these for them to show up? Stringify. That makes sense. Oh yeah, there should be none of these. This should be core stringify. Actually, stringify might just be in here. Okay, yep. Yes. It turns out if you debug print in your print, you get that. Okay, yeah, that makes sense. Okay, so I should be able to now, like, debug 5 plus 5. Can I do that? Yeah, look at that! Look at that! Look at that! Isn't that fucking cool? I'll just delete the comments. Fuck comments. Set text width is 79, actually. We'll go... ePrint ln. Be snide remarks of my father about your tattoos be ignored. Create file line. I think I just want to do file on line here. Isn't that fucking sweet? So I can like print socket and shit. God, that's so fucking cool! This is MIPS! This is MIPS on NT. It's fucking phenomenal. Take what's ours. What is rough? This love is ours. SP source print.rs. Boom. Print and debug routines. Okay. Socket for external prints communication. Okay. Writer structure that simply implements core format write such that we can use write format in our syscall, in our print. Okay, panic. SP source panic.rs. Panic handler. Then here, we're going to say panic handler. Okay, so now we can do mod print, mod panic. Okay. Okay, and then here we're gonna do unsafe FN register socket usize, and this is register the initial socket. Oh, and let's go to this repr transparent. Okay. Now what we're gonna do is this is gonna be a syscall handle, and then we'll register this socket. And the way that we'll register this is this unsafe pub super unsafe. So this is only public to the super. And then we'll do socket dot write dot store socket dot 0 ordering relaxed. Okay. We'll actually say release, right? Let me make sure release is correct, but I'm pretty sure it is. This function is actually not unsafe. I'm explicitly using unsafe to increase the gating. Release when coupled with store, yeah. So release that, so that's going to cause everything to be pushed behind that, which is good. Okay, and then what we'll do is we'll do print register socket. We'll even say this is unsafe. Fuck it. Register socket. Socket. Register the socket with the print handler so that we can print. Save the socket, debug, blah, blah, blah. Exit the program, and then here we'll do main. Okay. SP source. Entry.rs. Main program entry point. Entry point. This is like the exported entry point. Okay. That's just gonna call main. Invoke main. Create. Bam. Mod entry. Okay, and now we should be able to fn main. Now this is Rust and safe. Okay. So this will be create syscall handle, and then we're gonna have some syscall exit. Use create syscall. You know what? Handle, exit, and handle. Now that we're really tucking this away, I'm okay with this. And this will be crate print. Handle not found in the scope. Forever. Clear cargo check. I know it's like kind of hard to see some of the things here. Aren't you using the result from right? What am I gonna do with it? Entry. Oh. Pub unsafe extern FN. What component are you gonna fuzz? No idea. Print ln. Pub mod this. That should get me those. I think. Yeah. Okay. I'm trying to figure out why I have so many warnings and errors. I know this is covered by my face, but that's okay. Panic handler. Okay. Socket not found in the print scope? Yes. Shit. How are we gonna do that? Do we have to make this pub then? Do I have to make that pub? Okay, so... So this will be create, print writer. These have to be fully qualified paths, and that's why this is a little bit weird. Private tuple struct constructor. Okay, ordering. Here we can do this, I guess, up here, and then here we can say use core. Here I'll just do a FQDN as well. Fully qualified domain name. And then this has to be create syscall handle. Or no, yeah. Actually, here I can just say handle, and we can pull in syscall handle. Use create syscall handle. Okay. 59. Yep, this is create syscall, right? 11, create syscall. Oh, that's just handle now. Okay. Oh, that one still has to be full path. Yeah, that one does. 11 socket. This has to be create print socket. 11s. Yeah, and I have to make this public, which sucks. It sucks. It's kind of dumb. Kind of don't like that. I don't think there's a really good way around this. Obviously, I could wrap this in something. Whatever. Whatever. We'll just do this. Okay, handle is not FFI safe. that because I say it's transparent? So we'll just say it's repr C. Oh, yeah, I need to do that for handle. Bam! Bam! Okay. Watch. Bam! Okay, here we go. Here we go. Now, this is main. Print hello world. Okay, so now this shit is kind of hidden away from us. So that's going to register the socket so we can print. This is kind of like our kernel entry point. Register the socket, invoke main, exit the program. And then we can just return and exit and do all those things from here. So if we want to do results, how is this implemented for Rust? How do they implement main? Okay, so that's good. And then, is it just assert, okay? Oh, yeah. If let error x equals this, panic x. Is that literally what they do? Okay. Mismatch type's 10. Implicitly returns parens as a body, as its body as an blah, 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 blah. Oh, yeah. Okay, and then if I do error, and then struct moose, and this should fail if I say moose, because that doesn't implement debug. Yeah. Okay. And then we can see, main exited with error. Huh? Or do I not panic? Do I just do this? Main exited with error, like that, instead? Instead of having it be like an actual panic? Thoughts? Thoughts? Eh. You wanna panic? Desu wants a panic. Desu wants a fucking panic. There it is. Main exited with error. Moose. Okay. I don't know. I don't know. Okay. How is this dev environment now? Let me check what Rust does actually. Yeah. Isn't this fucking cool? All right. All right. Okay. Rust uses termination. Yeah, so I can't use that. So panic should be exiting. Boop. Okay. Yeah, now we can do whatever we want to do. Let's get Clippy in here. What's the cargo Clippy disallow unused Clippy where is it? Give me the punishment. Fuck yeah. Give me that. Give me that. Give me that. That's what I want. Clippy cargo bill cargo Clippy. Yeah, let's go. Make Clippy. All right, tell me what I'm not documenting. Moose, yep. It's fair. I haven't documented moose. Okay, what else do we got? Missing documentation and macros and print. Okay. Classic debug macro, classic print ln macro. I don't need to really explain these. Classic print macro. Okay. Missing documentation for crate. Okay. Main program entry point for Rust. Hey, we passed Clippy. All variants have the same prefix, NT. Yeah, that's pretty accurate. I don't know. What do I want to do? Do I want to allow this? Or do I want to do this? Where the fuck is this? There we go. Clippy being an asshole. Fucking Clippy, dude. I think Clippy is actually right, because we're making Rust bindings. We're not making just direct C bindings. And then here we can say allow unused. Or do I have to do allow dead code? What's the most strict way to say allow variant never constructed? Is dead code the best way, do you think? Allow dead code's a little bit aggressive, but I think that's okay. I think that's okay. Okay, there we go. We pass. Everything is documented. Get status. Get add source. Get status. Get commit am. Passes Clippy basic dev environments. Okay, get status. Okay, now we gotta go get the now we gotta go get the shit from the VM. So let's get this shit in here. Clippy is satisfied. Okay. So, what we're gonna do is inside of here, we want to package all this stuff up in a nice way, right? So think about packaging up this code like Desu, and then don't, because we don't want to package it up like Desu, because that wouldn't be nice. Okay, so let's see, new folder. What are we gonna call this? I don't know, like shellcode exec, shellcode executor, Nikito 97. shellcode executor, shellcode host, shellcode client, shellcode server, shellcode client. Paste. Remember you felt fit by the water. Okay, F rename. We're gonna rename this as client.c. And then this is gonna be spawner.c executor.c, or like listener. New rename listener server. Fine. Okay. New text document, make file. Okay, open that in MSDev. Okay. Okay. What? I just want to open it. All CL server.c winsock32.lib and CL client.c dosock32.lib. Okay. Shellcode client and make. So it should build both. Front of you saying I'm not, no logo. Nice. Nice. Okay. So now we should have a server.exe. Shit, we could, let's make this really fancy. Server.exe, server.c, client.exe, client.c. There's make in NT. There's been make forever. It's still the best way to do these things. Server.exe and client.exe. Okay, server, client. Boom. Okay. Make their source. Armature SQ source. Make their sources. Move star.c sources. Dir arm star.ob star.exe. Del star.ob star.exe dir. Okay. Sources. Okay. Okay. Del star.ob star.exe. Okay, let's keep going. Stop. 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 Objects. Make their objects. Is that gonna be a problem? I think that make there is gonna fail. Okay, nice. Server.exe, client.exe. Okay, and then this is going to fo obj server.object. I can't remember if that's the executable output or the object output. Clean. Armature SQ objs minus. Okay, and that's fine. That allows failures. In fact, we can even go and to null. Ah! Ah! Okay, CL. Oh, there is MIPS 4 support. Output files. FO, name object file. FE, name executable file. Okay. Okay. Probably should make a client. Yeah, but why? Why is it? Oh, you piece of shit. I might just manually link. Oh, I didn't delete the old ones? You're right. This is very difficult. Thank you. And make clean. And make. Ah! 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 Look at that! And make doesn't do anything. Fuck yeah! Alright. Yeah, that's some Giga Chad shit right there. If I've ever seen it. Okay. Okay. I can't. Oh, there we go. VSC? Is it VSC? What's the program called? Devenv? MS Dev. Let's get a round of applause for Big Fox 99 today, coming in with some of the biggest ideas. TY for lifetime VIP. I don't know what to say since the twist of fate when it all broke down. And the story of us was a tragedy now. Okay, so, Malik, good, receive, read everything. That handles the Felf, the alfalfa sprout. That looks great. This is great. Okay. And I liked it better when you were on my... Oops. Didn't mean to do that. Okay, whatever. Oh, well, we should be able to see that client will build now. Client and server and make. Okay, I'm gonna save client. Yeah, and just client should build. Hey! Ending soon. Now I'm sitting alone in a crowded room. Oh, T-Swift. So good. Okay, and then this is gonna be client.exe. Old T-Swift, best T-Swift? Yeah. Okay, so none of these should have hard-coded paths anymore, except spawn. Okay, so this is like literally wait for a client. Upon getting a TCP connection, just start a separate client process. This way the client can crash and burn, and this server stays running just fine. Okay. And then this is, we don't even transfer data. We just care about the connection kicking off a client. Okay, is this code good? So we initialize WSA, we check for errors, we initialize a socket, we bind to 42069, we listen for connections, we wait for a client, we do all this shit, and everything's great. Okay, that looks really good. Then in this one, we create a socket, check for errors, we connect out on port 1234 to fixed address. We read the payload, we read everything, so we keep reading until we've read everything. Once we've read everything, we check the felf header. If the felf header is good, then we get the entry point. We make sure that it's not a 64-bit address. We then try to allocate at that location. We make sure that it allocates at exactly where we expected it to. And then we mem copy the code directly into that base, and then we jump into the code and we pass in the socket that we originally had, and that looks pretty good. So if this builds and runs, we should be done. We'll do a clean all just to make sure everything's good, but I'm pretty sure we did everything perfectly because, yeah, we don't make mistakes. Okay, so now all I have to do is do a little watch and just do, write. Oh, I probably should launch the server. Server.exe. Okay, so server's running. Okay, and now write. And yeah, sure enough, there it is. There it is. Okay, and that's running through the new server. Okay, so that is really, really, really high quality code. That is now basically the best code that we've ever written. And how the fuck am I gonna zip this? How am I gonna exfil this file? Briefcase it, screenshot the VOD. Sometimes it blows my mind how useless chat is. D colon. Okay, shit, how do we do this? Fucking piece of... How is Clippy failing when we don't have main documented? Because it's not pub? If this is pub? What? Oh, is it just because it's main? If I said floop, does this have to be documented? Is it? Yeah, it's a special case for main. Okay, interesting. Interesting. That's good because otherwise I just put the / main entry point of program, and it's worthless. Okay, so now, and then NCW, that fails pretty fast. That's nice. Okay. Use SMB version 1. Trust me, no Trojan friends are inside that protocol. What do you mean? Okay, so QEMU mount. Okay, so then we'll go to MIPS test, make dir kimu, cd kimu, copy // kimu, nt kimu, and then run to here, vim run. ISO is this, okay. Okay, so I'm just having this in here so you can see exactly what the environment is. NT4 qcow2. I'm gonna copy NT MIPSL. Okay, MIPSL BIOS. NVRAM will get created by Kimu. Okay, so now there's our run.sh in here. Git status. Git add Kimu. Git status. Okay, so now all of those things are in here. So everything you need to basically replicate my exact environment is in here, except for the ISOs. Just go find those on the internet. And this will allow people to kind of play along and try these things out. Obviously, you have to make a hard drive, but that's easy. You should know how to do that. Okay, so now what I'm gonna do is the repo. It's not public yet. NT Kimu. Can we get some Kimus in chat? Some Kimus? It's probably like a P. I'm guessing like a P5. Yeah, I'm brilliant. Okay, copy from mount to Kimu. You fucking degenerates. Shellcode client to here. Get status. CD shellcode client. Make clean. Okay. RM null. RM client and server. Makefile. Makefile should also rm dir client.exe server.exe. ls slasher. Let's just make sure. Shishmod, makefile, and sources star.c. ls slasher. Okay, that's looking a lot better. Those look like fixed up things. Everything's good. Everything's copied. Git status, git add, shellcode client, git status, git commit. Am added Kimu instructions and shellcode clients. Git status. Okay, that's looking really good now. Now then, the final thing that we need is, I guess, so the makefile here will ship it out. So that will build it and then ship it. Clippy will check. Object dump will do object dump things. And then we want to we also need the self-serve. CD self-serve ls slash armor git ignore just git cargo clean lsl then source. It's just literally a self server. Git status git add self serve git status git commit am added felf serve git status. Okay, I think we're there. I think we're there. New repo. This is going to be called Rust MIPS NT4. Okay, MIPS Rust development environment for MIPS on NT4. Okay. All right. Okay. Readme.md. Okay. Summary. This is a project which allows us to run Rust shell code in a MIPS environment on NT 4.0. Toolchain. To use this, you need to copy the shellcode client into MIPS guest and run it, and build and run server.exe, included without any backdoors. Kappa 123. Yeah, we're just gonna include that because that might be kind of annoying for people to build. So we're gonna take the star.exe and put them in shellcode clients. LSL git status git add shellcode clients star.exe and readme git status. Okay. The server binds to 0000/420/69 and waits for a connection, TCP connection. Upon a TCP connection, the server inside the guest will launch client.exe in the same directory, which will then connect to the host via 192.168.1.2. Is it 1.2? Yeah, 1.2, which will connect to the host via that colon... 1, 2, 3, 4. To download the payload. We'll launch client.exe in the same directory in a new process. Set text width is 79. Okay. Okay, to download the payload. The reason we have client.exe in a separate process is so that we can crash it without problems. On the server, this provides a seamless debugging, a seamless development experience when you use something like cargo watch make, which will automatically use NC to tickle the server, causing the client to connect to the hosted felf serve, which then causes the payload to execute in the guest. The comms from the guest are sent to the felf serve over the socket that was used to download the shellcode. Felf serve. Felf serve is a server for felf files. You can find the felf converter at at here. How do you do this? Like here? Like that? You can find a felf converter at this. I can't remember if you need parens or anything or whatever. Just, yeah, I forget. You can find the felf converter at this. you need to install this to your path cat makefile. As the makefile invokes elf loader to convert the MIPS elf into a MIPS shellcode in the felf file format. Felf serve simply takes in how do we invoke this? Felf serve simply runs like felf serve 00001234 out.felf. It will listen to connections on 1234. It'll listen to connections on the IP and port you specified, and when connected to, will serve up the specified felf over a very basic protocol. This is what the clients.exe in the guest communicates with to download the Rust shellcode. Okay, I think, does that explain the whole process? I think it does. Git status, git commit, am info, git push. Okay, that, git commit am link, git push. Yeah, we'll just try it and prod. Yep, it's not that. I think it's this way. I think it's then this way. Yes, it is, and the syntax highlighting makes that pretty fucking obvious. Link, push. There we go. Thanks, chat. You fucked up. There you go. You just committed the exes. Yeah, that was the plan. That was the plan, because they're a pain in the ass to build. You'll have to literally install Visual Studio and then, like, import that shit and then, like, fucking build them. Now you'll need to set up 192.168.1.2, but, go fuck yourself. Okay. Have you ever had to fight some crazy lifetime stuff in Rust? Nah. Rust lifetimes are easy. Sudo umount mount2, sudo QEMU NBD disconnect dev NBD 0. Okay, I think that did it. Yeah. Self-serve, great success. Okay, there we go. So now we have a Rust development environment. Lifetimes in Rust are easy. Me after being 2 years younger than Composa, understanding shit of them. Yeah, they're not actually that easy. I'm just trying to flex. I'm trying to dab on the haters. Okay. Chat, raise your hand. Raise your hand. He doesn't see it? What? Oh my god. Oh my god. Oh my god. Oh god. Okay. Okay. All right. Do I have good dates? I think I do. Yeah, I've got good dates. Sweet. Clear. Okay. Let's go. Felf serve. Okay, and let's do one more. TLDR. Install NT 4.0 MIPS in QEMU using the command you see in QEMU run.sh, change the ISO path or remove it as needed. You'll have to configure some bootloader stuff in Arc, IDK, read a guide. Okay, let's go read a guide quick. Arc MIPS QEMU. Okay. TLDR. Blah 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 blah. Okay. QEMU run.sh. Okay. Okay, and then go through setup menu. Let's go find out what that setup menu looks like. FuzzOS. This. Okay. Okay. Run setup. Run setup. Initialize system. Set default configuration. 1024 by 768. Actually, we're using 1280. Choose your res. Okay. And then floppy 3.5. Second floppy no. SCSI host ID 7. Okay, any key that'll reset it. Default environment. That shit doesn't matter. Environment variables. Ethernet address. Set Ethernet address. To get access to CD:/ syntax. Okay, blah blah blah. No. Okay, and then set Ethernet address. So that is run setup, initialize system. Okay. Set Ethernet address. Pick an address. Must be a unicast MAC address, or Windows gets mad. Okay, I used this one, BE2D08345673 with great success. Okay, is there anything else we had to do? Great success. Okay, now you can reboot. Okay, now you can reboot. And then create the boot partition. Blah 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 to get access to this. Bop 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 bop. Now you can create the boot partition. Let's do this because this is boot partition. Okay, this is set up system so you can access CD. Set up Ethernet address so networking works in Windows. Create disk and run system. Boot partition. You must configure a small boot partition for the bootloader. Go to run program and then run this. A 5 megabyte partition will do. Okay, and then this is install Windows, blah, 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 setup loader. Okay, you should be good now. Okay, and then we can say this. Configure time. Yeah, fuck it. Configure time. The time in Windows doesn't persist. Set it inside Windows to something reasonable. Otherwise, you'll get weird errors, and cl.exe will not work, so you won't be able to compile anything. Okay. Yeah, I think that's pretty good. TLDR, do that. We're gonna say, setup NT. Blop, 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 blop. Okay, and then, now we can use the tool, deploy, server.exe and client.exe to the system. Then, run server.exe inside, QEMU. Then, self-serve. Okay, install self-serve to your path, cd self-serve and cargo install path dot. Okay, run self serve, supplies code to guest over network, and standard out prints from Rust running in guest. Okay, so that. Okay, and then once we do that, then we run make, or to build and deploy to MIPS. Optionally run this cargo watch make to get your code to redeploy and run every time you change the Rust project. Okay, get status, get add read, get commit, updated readme, get push. Okay, how's that? How does that read, chat? Anything that is confusing there? Run setup, get run program, blah, 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 install Windows, that, configure time, use the tool, deploy server and client to the system, run server inside QEMU, install self-serve to your path, run self-serve, okay, bop. Okay, and then run server inside QEMU, install self-serve to your path, run self-serve supplies code to guess over the network and standard printouts, self-serve that, run make, and deploy to MIPS. Okay, let's double check that. So let's make sure everything works. So we're gonna boot Windows. Everything's fine. People should be able to figure out how to install Windows. Did you want to do the MoveZ thingy? No, we didn't actually have to do that because we picked a processor that supported MoveZ. We picked a MIPS 4 processor, and it's fine because Windows NT is compatible with that, and we're good. So then we go into shellcode. We run server.exe, so we're just running that. Okay. Now we're going to run self-serve as mentioned, and then we're going to run cargo watch make as mentioned, and it's working. It's literally just working out of the box. So those are all of the things that we actually need running on the system, and everything should be good. Okay. Okay. Okay, so other people should be able to reproduce this now. Yeah, that's pretty cool. Pretty cool. All right. Sweet. So, this was a moment. Yeah. There you go. Now we can start playing the game. We can close that. Let's just close everything. So this is our main program. Pretty good looking thing. Just works. Okay. Who wants a shout out? Who wants a shout out? Raise your hand if you want a shout out. Let's see who's gonna be first. Who's gonna be first? Manatee Appreciator. Okay, there we go. There you go. Hello world. Manatee Appreciator. There you go. On MIPS, right there. Is it not possible to use the host local time by setting some option in Kimu to avoid the issue in Windows NT? Yeah, you could configure like NTP, and it'd be fine. But NTP on Windows is like pretty spotty, honestly. Okay. 172 bytes. Why is it 172 bytes? That's so big. Oh, yeah, I guess exit and syscall and that and jump in link to MIPS syscall 2. Why is that so big? Manatee Appreciator, thank you so much for the sub! Hell yeah. So all of this is the header. We've got some like data-y stuff in here. We could probably minimize it. We don't really give a shit how big this is. Self-serve. I just don't know why that's so massive already. 172 bytes. What would be in there? Okay. Target release, target MIPS release, MIPS test. Oh, I want to document something quick. Okay, these wrappers use Rust naked functions. And the fact that the Rust and the 032 Rust emit C ABI matches the Windows kernel ABI. This allows us to simply move the last parameter into last parameter syscall number in our Rust bindings into the correct syscall ID register, which is VZ, and pass through all existing parameters. This decreases the amount of overhead and means we don't have to worry about things like register homing and stack alignment, as those are handled for us. Set text width to 79. It also may be a bit confusing why we don't ret from the syscall. This is because syscall MIPS actually returns to the user provided LR, meaning the is that fucking true? Yeah, I mean, I guess it's not. What is it gonna do? Return to some fucked area? So it's not really a big deal. User provided LR, meaning the LR is set from the call to the naked function. Thus, the syscall directly returns back to the caller of the syscall star wrapper function rather than to the instruction following the syscall. Okay. I think that's some good clarification. You understand like how this shit works. Thank you so much, H3 SSTO, for the tier 1 Subarino. Hell yeah. Okay, and then we'll do, necesito, add el comando para, add command, para MIPS NT está bien porque todos los viewers necesita un way para read. I know read. I should know read. Correr. Para correr. Sí. Leer. Leer? Leer is to view to para correrse. Leer. Correr is run. Yeah, correr is run. Yeah. Para run. Read is leer. Yeah, there we go. Whew! Está bien. Yikes, it's been a hot minute. If it's not obvious, it's been a hot minute. Okay. So, now what we can do is some fun stuff. Chat, raise your hand if you're ready for fun stuff. Syscall.rs. Generic syscalls for Windows. Everything in here should be architecture agnostic. Okay. Quererse is to touch yourself. Está bien. Okay. Exit. Terminate process. Unreachable unchecked. Okay. Muy bien. Muy bien. Okay, so we have this NT status. NT status. This returns the number of bytes written. We could make a wrapper around that. But first, here's what we're gonna do, chat. You ready? You ready to go from 0 to hero really, really, really fucking fast? The answer is yes. Chat, you're supposed to say, yes, I would love to do that. That sounds fantastic. Okay. We don't want MIPS test. We want kernel32.bindb. Or do we want ntdll.bindb? Okay, let's go, and we want NT allocate virtual memory. And this is, yeah, even these ones don't have rets, right? It's not just us, chat. Quererse your ding dong. Sick. I don't know why that's funny. That shouldn't be funny. That's terrible. NT allocate virtual memory. This is mmap. This is mmap. And the way that we write mmap is we have an A. Okay, and then we go down here. Yep, because that's OS specific. And then we'll go down here and we'll do allocate virtual memory pubfn mmap. Process handle. Yeah. In the current process. Okay, so we have an address, usize. We have 0 bits. Number of high order address bits that must be 0 in the base address of section view, used only when the operating system determines where to allocate the region, as when base address is null. Note that 0 bits is larger, when 0 bits is larger than 32, it becomes a bit mask. Number of higher order bits that must be 0, it doesn't matter. Size, and U8. I think this should be sufficient. Yeah, this should be fine. Unsafe. Okay, and now we're gonna do status is NT status, blah 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 blah. NT status. This. Result. Result this and good. Let's just start with this. Let's not get too crazy here. Let's just do syscall 6. Okay. Bink. Okay, bank. Process handle, not 0. Okay, done. Base address, let's mute address, and then this will be adder of mute adder. As use size. Okay, this is the 0 bits. Doesn't matter. We don't care about the number of 0 bits. This is the region size. Does that have to be aligned in bytes? It is rounded up to the next host page size boundary. Cannot be 0 on input. That's fine. That will just return an error. Allocation type. We want commit reserve. We want commit or reserve. Okay. And then down here, we want the page read write. Honestly, not too bad. And then this is the syscall ID. And this is syscall allocate virtual memory. Okay, we're pretty close. Let status is equal to NT status of this as use size blah. Okay. Print status. Kind of amazed that there isn't a reversing tool made by Gamozo and Rust. You could call it claff. Sick. Okay. Print if let error is equal to status. No. If return allocation, otherwise return status. And it's not ISB in this case. This is actually going to be adder at this point. So this will be adder. If it's success, then we have adder as mute U8. Okay. Adder of mute. All right. There we go. Bink. Wow. This is going to be good, chat. This is going to be good. Oh, this is an in-out. That's a P size T. Adder of mute size. Okay, so that's mute size. Bam! And I bet if that's not mutable, that's gonna fail. Or does this not care? Okay, it doesn't seem to care. So we're gonna make sure that both of those are marked mutable. So we have an address and a size. Okay, adder of mute as use size, adder of mute size as use size. Okay, so those are the in and outs. Those are ins. That's an in, that's an in, that's an in, and then we just need these flags. Oh, Mipazora! Yeah, it's not British. This is Italian for some reason. Mipazora wants a British accent. Okay, so we're gonna go and we're gonna go explore inside of here. We're gonna go for a small little exploration. We're going to go start CMD. CMD is going to tell us exactly what we want to do here. So we're going to go into, let's check out hello world, because that's, we should just be able to open this. Hello world.c. And we should have make file. We do have a make file here, but it's fucking useless. So we'll include windows.h. Once we got windows.h in here, we should be able to go down and print out some of these constants. So we're going to do printf %d and a %d. Actually, we'll do hex. Another one, mem commit mem reserve. And page read write. Okay, that sounds good. All right, now we're going to here. cl hello world.c. Oh, gotta set the time. Gotta go and set the time, chat. Whoops, we fucked that one up, didn't we? Classic Windows. Oh, time's too far off. Okay, bottle of water. Hello world.exe. Okay, we've got a 1000 hex. We've got a 2000 hex. So that's commit, reserve, and then page read write. Okay, so let's go establish these constants. Yeah, let's go say const mem commit is u32. We'll say it's u32. 1000. 2000. A minute is over. Get fucked. Yeah, that's what people wanted. That's what people wanted. That's what the people wanted. Const page read write u32 is it was 4. Is it 4? 2004. Okay. So, commit memory, reserve, memory range, readable, and writable memory. Okay. Ah, shit. This Brit spent too much time in the Irish pub. Mo's like, thank you so much for the Twitch Prime. Hell yeah. Hell yeah. Ah, shit. Mismatch types. You know what? I'm just gonna keep trying variables until it works. Okay. So this should invoke this. This should invoke this. Yeah, yikes. Yikes. Man, that's what keyboard to use. It's DOS keyboard. It's Cherry MX Blues. Blues Clues. Syscall mmap 0 1024. Is this gonna work, chat? Is this gonna work? Can you debug print pointers? Oh, we can even... Oh, chat, it's about to get fucking crazy. Oh, we're about to do some crazy things here. Oh, welcome to the Mega Dome. Today we're gonna be adding some ability to do some allocations to our system. And yeah, that was fucking first try, wasn't it? Come on, brother, we're gonna go in here. We got monster trucks, we've got allocators, we've got everything that you could possibly want. We're gonna do a little extern crate alloc, and that's gonna pull in an allocator. Then we're gonna have to implement an allocator here, and that's not gonna work out of the box. We can do a default error handler. We'll just get one of those going right now. If you call now, you'll be able to get all these features and all your code anytime you need. I'm Doug Dimmadome, owner of the Dimsdale Dimmadome. Ah! Woo! Woo! Okay, memory manager, okay, the global allocator, static global allocator. Allocator is a global allocator, which is a global allocator. Yeah, this is a global allocator. Okay, and then we're gonna say global allocator. We're just gonna say struct. Implementation of the global allocator. Okay, global allocator, the object. Okay, and then we'll impl. Okay, that's like probably close. Mod mman. First time I've been here, and I'd like what you did. Oh yeah, I still have it bass boosted. Sorry for the bass. That voice acting was good. I think he's still high on those Krispy Kremes. Honestly, it took 2 days to come down from the Krispy Kremes. It's pretty fucking bad. Okay, so impl global alloc for a global allocator. Okay, and then we'll do fn alloc. This takes a layout, which is a layout. This yields a mute u8. Standard point, core pointer null mute. Core pointer null mute, and then this will take this is a dalloc. Adder mute u8, something like that. That looks pretty good. Okay, and that, Okay, and then we'll do use alloc layout and global alloc. Okay, so there we have those traits. It requires an unsafe impl. And we're probably pretty much there. Both these take selfs. Okay, they both take a self. And then unsafe fn. Okay. All right, so then we should be able to do syscall mmap 0 layout.size unwrap or core pointer null mute. Okay, so that's going to attempt to do the allocation, and if it fails, it will be null mute. And then dalloc will just not do anything for that. Okay, here we go. Syscall. This is going to be create syscall mmap. All right, and then I don't care about the address here, and we don't care about the layout here. Bam! All right, so now what we should be able to do is, Can I macro use on a crate? No. How do I get, let foo is vec ou832. How do I get this? How do I get this? Oh, I can macro use on that. Oh, okay. So that's what you're supposed to do. Do I have string new? I don't have string. Okay, what's the, is there not a prelude for alloc? I think I looked at this yesterday, and I surprisingly didn't see a prelude for alloc. How to make your program fast, don't ever call free. Yeah. Alloc prelude. Okay. Put this down here. And feature alloc prelude. Okay. Is this gonna work? No. No. Is this not a thing? Alloc prelude. Let's see the current status on this. Tracking issue. Oh my god, did this seriously remove to announce? Closed. Oh, remove alloc prelude. Fuck. So it looks like that's gone. They actually removed that like a couple days ago. Prelude module and alloc is auto-imported, blah, blah, blah. Okay. Well, maybe we can't do that. Macro use. Unused. Do I just do this? Allow. And then get rid of prelude. Okay. Let foo equals format ASDF. Right? So now I can print foo. And now I have an allocator. Woo! Look at that shit. Let mute foop is equal to vec OU8 1024. We can allocate a meg. You want a meg? You wanna see what a meg looks like, chat? That's what a meg looks like. Foop. Right there. Pointer. Dot as pointer. There you go. That's what, there you go. Now we have an allocator. And further, we could go and do some of this. You want to, like, see what's in that memory, chat? Boo! Might take a while to print a meg. That might have been a mistake. Okay, so now we have an allocator and we can do whatever we want. So now we can go and implement NT free virtual memory. Okay. mmap. Chat, you made me do this. You made me do this, chat. NT free virtual memory. ZW. Okay. 3A. Free virtual memory. OX3A. NT free virtual memory. Pretty straightforward there. Oh, no! No! I keep rerunning it. What has that done to my VM? Oh, boy. Yep. Okay, Control C, Control C, Control C. Okay. Technically, we don't really need these things open right now. Control Alt G. Release grab. There we go. Close this. Close. 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 Okay, we're running just the server. All right. Okay. Now everything's fixed. Okay. Okay. Create syscall free. I think mmap can be safe, but munmap probably shouldn't be safe. We'll just say adder here. Okay. So we have the address. We'll pass the address in. The layout. We don't care about the layout. And then free. This syscall will actually make unsafe. We'll make it so you can map things in, but we're not going to make it safe to unmap things. Right? Pub unsafe. Deallocate. Memory in the current process. Address and size. I don't know if we're going to need size. Base address. Okay. Basically the same thing as this. Okay. I mean, we're not really... we can return the code. We will. Okay. This is a result. Blah, blah, blah. And if success, return... return... If success... return error on error. Okay. If it's successful, then it's okay. Otherwise, that. Okay. NT status. And this is a 4. This is a 4-banger. We got a process handle, that's that. We got a base address and a region size. We don't have 0 bits. Both of those are read-writable. And then we have a free type. And the free type is decommit and release. This is free virtual memory. Okay. So now what we need to do is region size. Pointer to a variable that will receive the actual size in bytes of the freed region of pages. The routine rounds the initial value up to the next host page size, blah, blah, blah. If the release flag in free type is set, deref region size must be 0. So since we are doing a release, this actually has to be 0, and that's what I remember. Let mute size is equal to OU size. Region size, right? So that region size will be 0. It'll be a pointer to 0. It'll get filled in with the actual thing, but when you call release, you have to have that be 0. Free virtual memory frees the entire region that was reserved in the initial allocation call. If the decommit flag is set in free type, it decommits all memory pages that contain 1 or more bytes in the range, blah, blah, blah. Okay, decommits the entire thing. It decommits the entire region if the following conditions are met. Decommit is set. It is. Base address is the base address returned when it was given, and region size is 0. So this should be good. Right? This should be A-okay. All right, so mem decommit and mem release, we got to go grab those as well now. cmd cd hw hello world dot c. Okay, and then mem decommit and mem release. cl hello world dot c. Okay, 4,000 and 8,000. NT is such a beautiful OS. Yes, it is. It really is. I love it. 4,000 and 8,000. So this is decommit. Let's make sure I have the ordering right. Decommit and release. Release memory range, decommit memory. Release and decommit. Okay, free. Yep, it's not called free. I called munmap. And then that one is actually unsafe, and that makes sense. Sweet. Consider a semi. Here. Expect failed to deallocate memory. Do I care? Do I really care? No, I don't care. Just let that shit leak. Let blah is equal to this. Okay, and then this is as usize. All right. This could actually, in this case, take a mute. U8. I'm fine with the usize. I actually like usizes for addresses here. Unnecessary unsafe block. Okay, where? Oh, here. Yeah, that's fair. NT status syscall 4, which means this we can go boop. Okay, and then this. That looks great. Okay, and this is perform syscall. I'm gonna add this to all these because I don't like the comments that I have right now. Perform syscall and perform syscall. There we go. Beautiful. Okay, so what we should be able to do is we should be able to go to dealloc. We should comment this out, and we should be able to just do this. Loop let blah is vec OU8 1024 by 1024. This should eventually fail and crash. Oh, I see. I see. Okay, so there we go. Yeah, allocation failed. Sweet. So then, if we put this in, we hopefully can now run this program, and allocations won't fail. This should just churn forever, and we shouldn't really be increasing our commit size. JK lol. Decommit and release. What's going on there? Why is that growing? Why is that growing? What? Why? Hello? Failed. NT status that. Okay. Python hex this. COF2 CONT status codes. Let's go figure out what we're doing wrong here. You don't have to decommit in 2 different swoops, do you? F2. Invalid parameter 4. The 4th parameter was invalid. Okay, first of all, who the fuck uses invalid parameter 4? Nowadays, they just use invalid parameter. That's really interesting. Invalid parameter 4. Can you not do both? 4,000 and 8,000. 4,000 and 8,000. Do you have to decommit and then release? I swore you could do both, but maybe not back then. Can you not do that back then in the thing? Probably only need the release. Okay. Yeah. Okay. We'll release it. The pages enter the free state. Region size must be 0. Base address must point to that. If they're committed, it decommits and then releases them. Okay, yeah, I guess, yeah. All right. So that means we can get rid of decommit. All right. So then these we can kill these processes, and yeah, we have 100% CPU usage when we do this. When we build this, that ships it off, and it's allocating. It's allocating over and over and over again, but it's not actually using more memory, which is fantastic. That's exactly what we want. Select columns. Let's get memory usage. Virtual memory size. Here we go. So we have the is mic and cam desynced? I don't know. Probably. Test. It's hard for me to say. It's hard for me to say. I don't know. Is it? Refresh. Think we had a small F. Okay. All right. It's desynced. Like 1 second. Yeah, I'm seeing that right now too. I don't know why that's so far behind. It's not when the program is running, is it? Test. That's really weird. Test. 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 Yeah, it's still off. Move. Yeah, what the fuck? What? How? How? It most likely OBS is drunk. Yeah. Test. Nope. Test. Nope. Test. What the fuck? Where did it all go? It was fine. Yeah, I don't know what's going on there. That's really strange. That doesn't make sense, unfortunately, chat. Well, you're just gonna have to deal with it for now, because I'm guessing it will fix itself when OBS restarts. I could also check. I could do this. Check this out. VLC dev video 0. Is it video 0? Is it not that? FF play dev video 0. Yeah, it's fucking VLC. Or it's not VLC. It's OBS. What the fuck? What the fuck? Let's see. Well, that makes no fucking sense. You can force kill OBS and restart it without streaming going down? Really? Sounds risky. Old busted software. Huh. Now move this window in front of the cam. That's really fucking weird. That's so fucking strange. I'm gonna change the resolution of it, and then I'm gonna change the resolution again. Test. Test. Did that do it? Test. Yep. There we go. Just change the resolution. There you go. That caused some Alex and freeze in the right way. Okay, so let's take a look at our process. Are we not running it? Did we close it? I think we closed it. Okay, let's Control W or build. Okay, we built. Okay, that allocated. We've got 100% CPU usage here. Memory usage 1404. Oh, that's climbing. Oh, it's not. Okay, it's pulsing. Nice. Okay, that looks good. It looks like that is correctly staying in bounds. It's not growing. That's exactly what I want to see. So that is how we know that that's working great. All right. All right. Nice. 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 Okay, so that means yeah, so base address, region size, don't care about anything. If it was successful, mun map, we do an unwrap. Here we'll say expect failed to deallocate memory, and fuck it, we can leave that panic in there. I'm not a scaredy cat. I'm not a scaredy cat. So now this is failable because Alec, I think global Alec, yeah, global Alec can return null, and that's fine. Because we saw it fail, and when it did fail, we got the panic. We got, like, an actual panic. Then dealloc, we actually make sure that that succeeds. So if we take this and we add 1, this will probably fail. Yeah, that failed. Fantastic. Okay. Nice. Nice. Okay, so now we can allocate things. All right, so this is beautiful. All right, let's see what Clippy has to say. Oh, we're nailing it. Make Clippy. Oh, make Clippy. Oh, wow, even that. Holy shit. I can't believe it. Okay, let format is equal to format moose this vecchi.as pointer. Okay. Vecchi. Okay. P, and then we print line this format. Okay. So now that is there we go. Moose CB. Nice. Oh, nice. No SLR? Yeah, definitely not. Okay. Git commit am added allocation support. Git push. Woo! Okay, so oh, we can do so many fucking things now, chat. Oh my god, we can do Vex. We can do literally anything in Alec, which is so much stuff. There's so much stuff in Alec. Like, oh my god, look at this shit, chat. Look at this. Look at all the things that we can do here. I hate how the theme doesn't really do anything in Rust. In like local documents, it just doesn't fucking work for some reason. Like every time you click on something, it like goes back. I don't know. Enjoy your eyes getting bleached. So here's all the things that we can do. So format and vec, obviously those are the macros. We can do these are the Alec stuff. Borrow, so we have cow. We have access to cow now. We have access to boxes. Eyes get fucked. Yeah, let me just put everything in light mode so it just stays. We have collections, so we have binary heaps. We have B-tree maps. We have B-tree sets. We have linked lists. We have vecdex. We have format stuff, so extended formatting stuff that we get here that requires allocations. We have RCs, so we have ref cells now, and weak, of course. We have what are these? Slice. Are these extensions to slice? Chunks? Does chunks require allocation? I don't think so. What? Functions from mute from reports. I don't quite understand what slice is extending, what it's extending it by. Maybe, yeah, I don't know. Sync, we got arc, of course. So now we have arc, task, wake, and vec, which is vec. Okay, so now we can do whatever the fuck we want. Now we can do like, isn't this so fucking cool? Check this out. Foop is equal to B-tree map new. Use Alec B-tree map foop dot insert 5, and then we can do like an OU. Can I do a 128-bit integer? Collections. Do you think I can do 128-bit ints? Yes, I fucking can. Yeah, I get fucked. Foop. Okay. So yeah, look at that. Look at that. 128-bit integers. Yeah, let's fucking go. Isn't that fucking cool? We have sets, we have nice prints, we have all this nice format stuff. Oh, it's so good. It's so good. It's so good. It's so good, chat. Do you have threads? Yeah, I mean, I could do NT create thread. How hard is NT create thread? Honestly, threading will probably help with finding bugs. So I might actually want threading. NT create thread. Let's see. Huh, is it not documented? Interesting. Interesting. Do you have to allocate a tab for it? Get context thread. Huh. Huh. Already running into undocumented NT calls. Yeah. All right. NT create thread. Yeah, yeah, exactly. Yep. That's basically what we're gonna have to do. A thread handle that gets one. Desired access, that would be like Object attributes, optional, so none. Process handle, that's not 0. Client ID. Okay, let's go and let's try and bang this out quick. Unsafe, syscall, syscall, 1, 2, 3, 4, 5, 6, 7, 8 arguments. Syscall 8. Okay, syscall. Let's just implement it in here. Okay, that's good. That's done. That's done. Actually, we needed that file open. Spawn thread. Pub fn spawn. Okay, and then we'll figure this out. Spawn create thread. NT create thread. Yep. Okay. SP source syscall MIPS. NT create thread is 24. Okay. Create thread 24. NT create thread. Okay. That looks good. So now all we have to do is actually make the syscall. Shouldn't be too terrible. We have a thread handle. Let mute handle is 0, usize. Adder of mutes handle as usize. Then we have desired access. Let's just say 0. Attributes. Let's just say 0. Process handle not 0. Client ID. The fuck is that? It's a fucking client ID. I'm just gonna assume it's that. Adder of mutes, client ID as usize. Let's just say this is an OU size. Thread context 0. Oh, whoa. Supplies the initial contents of the tab. Create suspended. Oh boy, those are really hard, I think. I think you have to actually... Oh, shit. Initial tab. Stack base, stack limit, commit, commit max, stack reserved. Thread context. P context is a bitch. P context is an absolute pain in the ass. Like, P context is gonna be brutal, unfortunately. Grumble, 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 grumble. Grumble, 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 grumble. I've done harder things in my life. So context, you're gonna have to set. You're also gonna have to set. Might be WinDef, might be WinBase. I'm not sure. It's probably like WinBase or WinDef. Oh no, these are all separate instances. Whoops. Oh, I pulled these down, didn't I? I pulled down the includes. MIPS test, NT, MSDev. Oh, thank God. Thank God. Okay, that's not terrible. That's not really that bad, actually. Okay, so this is the initial context and initial tab. Do I have initial tab? Probably not. That's not the sort of thing that would be in here. Yeah. Okay. Context frame, several purposes, blah, blah, blah. Construct this. Call frame for exception. User level thread creation routines. Pass thread state to debuggers. Because of this record is used as a call frame, it must be exactly a multiple of 16 bytes in length. 2 variations. This is the real one. Okay, that's great. Context full. So you can set these. So basically, you can set like the specific control flags, but I think just one would probably be fine. I don't know what context alpha is, but I could set that. And then fill padding for 16-byte stack frame alignment. Okay. If it's used as an input parameter, then each portion of the context record controlled by a flag whose value is set, it is assumed that it is a valid context. Okay, let's fucking do this. Oh, and if it's being used to modify a thread's context, only that portion will be modified. If it's an in and out, okay. Yeah. Let's fucking go. Let's fucking go, chat. Syscall. Okay. This is the one, dude. This is the one. Everyone breathe in. Everyone breathe in. Everyone breathe in. Floats. Yeah, there we go. Good. Good job. We got 32 floats. These are Dwordlongs. What's a Dwordlong? D-word-long? Is that just a U30? Yeah, that's a U32 because, MIPS has the weirdest floating point architecture in the world. Oh my god, yeah, MIPS, you use floating point pairs when you want 64-bit. They're actually all 32-bit registers, and then you do pairs. Okay, then we have 32 of these. Okay, then we have FPCR. Software extension to FPCR. Okay, and then we have the FIR, fault instruction continuation address. Shorty got them apple bottom jeans, boots with the fur. Processor status, PSR U32. Okay, and then context flags. And then fill U32 for 4. Filler to pad to 16-byte boundary. And this is the context flags. Okay, let's make sure everything adds up here. 32 plus 32 plus 1 plus 1 plus 1 plus 1 plus 1 plus 4. That's 73. That doesn't make sense. 32 plus 32 is 64. Plus 1 plus 1 plus 1 plus 1 plus 1. That's 69. Nice. Plus 4. That's not... floats. 32 floats. 32 ints. An FPCR. A software FPCR. A FIR. A PSR. A context flag. And a fill. What is a Dwordlong? Is Dwordlong 64-bit? Do you think a Dwordlong is... Are those 64-bit? Let's go find create thread. Let's take a look. CSR new thread. Context. Set thread context. Okay, we're just gonna YOLO this. We're gonna assume that these are 64-bit. FPCR is a word long. Soft FPCR is a word long. A FIR is a word long. A PSR is not. Context flags is not. Okay, so now we've got 64 plus 64 plus 2 plus 2 plus 2 plus 1 plus 1 plus 4 is 140. And is that evenly divisible by 4? Yes, it is. Okay, I think we did it. www.wedidit.com.co.uk. This is the context structure. Okay. Woo! All right. This looks good. This looks good. This looks good. This looks good. .com.co.uk. .nz.mx. Dot whatever. Okay. Okay. Let mute context is context default. Okay. Consider importing this structure. Maybe if I made this pub, then we'd be fine. Last time I had to write short, long was for the Goldosaurus. Interesting. Yeah, word long is just interesting because I've actually never seen word long. I mean, I know D-word and long and all those sorts of things and how those are different, but this one was a little bit of a bitch. Okay, so then we have NT create thread. So then we have a thread context. So this is address of context. As usize, that's probably an in only, and then an adder of tab as usize, initial tab. Okay, and then we're just gonna debug this, and then we'll call spawn, and then we'll be good, and then we'll call syscall spawn. Okay. Syscall, what's going on here? Yeah, no. Adder of, yep, Bam! Teb, not found in this scope. Okay, let mute teb is equal to OU8, that. What? Woo! Woo! Oh my god. That's a Q5 of null. Oh my god, is it just trusting an address I'm giving it? Wow. 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 Well, that's a thing. Remember when BSODs were useful? Yeah. Oh, we're getting check disked. Oh, we're gonna fucking destroy this VM. $5 it works on Win Server 2K3. Okay, so I was about to make a joke and say, well, we can play around and like try things until it works. But we might actually have to make sure we get this right a little bit better from the start, I guess. We might not just be able to do that. Adder of mute handle. Okay. Yeah, that's an output handle. That looks good. An access mask. All right, let's go take a look at an access mask. Process all access. That's a good one. That's one of my favorite ones. Let's set our date and time. Okay, that might break it just as bad. Okay, CMD CD hello world. Hello world.c. Okay, let's see if we can just do a process all access. Actually, I don't think we need access to our own thing. Or not process all access, sorry. Thread all access. I don't think we need that. Oh, fuck. I ran it. God damn it. Ah, son of a bitch. Well, it repros. So it wasn't a fluke. Yeah, it's definitely not a fluke. I can tell you from the feel of that bug, it's definitely not a fluke. It's just server. Broke the 190 proof. Everclear and cranberry juice. Oh my god. Every time we have to start NT. Oof. Oh, I saved it, but luckily I closed the thing. Okay, address of handle. Yep. Thread all access. That shouldn't matter. Null. A process handle, which is our own. A client ID. The fuck is a client ID? Returns the client ID of the new thread. Looks like it's a two handles, actually. Looks like it's like this, two. Looks like it's two handles, according to this. Process and a thread handle. Yeah, I remember doing that. Yeah, I totally remember that. Client ID, yeah. Okay. So you have a client ID. Then we have a, a thread context. And I don't know if the tab matters. Initial tab, I think, is output. Maybe not. It's kind of scary. This one has tab being uninitialized in one of these. Okay, so we can probably have tab be uninitialized. Let's say OU64. Let's make sure that it's 64 byte aligned. Yeah, OU64. Then we have a context, we have a tab, and then the context, let's actually set some things in the context. So let's set a stack. Context flags, we'll do context full. So let's go and figure out what that code is. Actually, we can probably just get that from over here. Tag context full. Ooh, 32-bit context frame. Fuck. Oh no. Ooh. Ooh. Hmm. 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 They can operate on the fields and valid declared as pointer. Let's see if this is defined. Portable 32-bit context. Let's see what we got. Hello world.c. %d size of context. Fuck you. WinNT.h. Okay. WinNT. Oh, this is struct context. Yeah, I was about to say WinInt shouldn't have to be included. Yeah, that's pretty classic. That's just a bad date or time. It's pretty standard that can happen. 568. Okay. What is ours? What is ours? 32, 32, 32, 32. 1, 1, 1. 1, 1, 1. 1, 2, 8. 5. We have 560. And padding. I probably miscalculated to padding. Ooh, that's looking maybe juicy. Let's see. What's a telltale? What do we have for an oracle here? Honestly, if these exist. Struct context moose is 0. And then we're gonna printf moose dot whatever the fuck that was. High float f0. Okay, if this fucking builds, then we know. Hey, okay. And then further, we can verify. Do we have another way? Fill. We can also do size of fill, because fill is 4 on that one, and this one it is 2. So let's do one more. Oh, that's high fill. Yeah. Okay. So that's an oracle. Another one. So fill. Size of moose.fill. Okay. So if this builds, we know that this exists. Okay. That's not good. That's not good. That's not good. Ooh. Is there a high fill? Is there a high fill? Did I typo the float and this is gonna exist? No. No. What? What? But oh, how many fucking contexts are there? That's x86. This is MIPS. What the fuck is this? Fill 3. Oh, that's x86. If not defined, portable 32-bit context. I bet we have a portable 32-bit context. So it's going to be one of these next ones. It's this. It's going to be fucking this. Isn't it? 32-bit context is a union of a 32-bit and a 64-bit context. I told you this was gonna suck, chat. Fucking told you it was gonna suck. Xint low. Let's see if this exists anywhere else in this file. No. Xint low is an oracle. I think that's how you spell it. Oh, L-O. It's that one. Oh, mamma mia. Always present and is used as an argument build area. Context records are 0 mod 8 aligned, starting in NT 4.0. Okay. So that is 16 bytes. Weird. Okay. All right. Well, we got context. We got a 64 and a 32-bit context. So let's start with 64-bit, 31 floats, 2 fills. So 32 U64 floats, 2 fillers. Then we have an XFSR, which is the U32. Then we have an XFIR, and we have an XPSR. Okay, XFSR, XFIR, XPSR. Then we have an X context flags. Okay, and then we have integer registers, and we have 34 of them because the low and highs are included. Interesting. Okay, that makes sense. Okay, that should be that structure. 34 U64s, D-word longs. We have a context flag. We have XPSR, we have an XFIR, we have an XFSR, and we have 2 fills, and that should be good. That is context 32. Okay. Now, that's a context 64. Floating point, yep, 32 of those. Okay, so now we have a context 32. Does Windows even have a public kernel debugger? Yes. It has forever, and it's better than any other kernel debugger for any other system in the world. It's unbelievably good. Floating points. So these are 32 32s. Then we have 32 integer registers. Actually, that looks like 34 because we got low and high. Okay, then we have the FSR. We have the FSR, the FIR, the PSR, and the flags. FSR, FIR, PSR, and flags. Yep. And this is the 32-bit context. So this is the status register. What is FIR again? I had names for these before. That we're good. FSR, FIR, and PSR. FSR, FIR, and PSR. FSR, FIR. I don't know what FSR is. Probably like fault status register. FIR. PSR, processor status. Okay. This should be correct. FSR for these don't need to say X. That's just how they did it because they used anonymous unions. And then PSR, you can put here. Okay. So that's context 32, and then we can do pub struct context. And the whole context structure is a union of those two and a union of these. So we're going to do a union pub union union context align. And this is argument U32 for 4 and an alignment, which is a U64. Okay, so we should have a align, context align. Okay, cargo check. That's pretty good. So we don't have defaults for those. That's okay. We'll just go and rip those out for a second. And we'll temporarily comment out all of this. And then we're making progress. Slowly but surely. Cargo check. Okay, that looks good. All right, those are passing. So this is alignment structure. Alignment structure for context. Context. Okay, this is argument. Alignment. Okay, so U32 for 4, and then we have a U64, and then we have another union, and the union's going to be a pub union context bits union of different bitness contexts. Okay, and this is going to be a bits 32 context 32 and bits 64 context 64, 64-bit context, and this is a 32-bit context. Have you ever worked as a sysadmin? Nope. And then we have the context, and this is context bits, contexts. Okay, and this is architecture or bitness agnostic contexts. Okay, untagged unions. Unions with non-copy fields other than manually drop or unstable. Okay, derive, clone, and copy on this then. If you're gonna be a bitch, then fuck you. All right, adder of, good. Okay, so let's print the size of that quickly. Print this core mem size of struct size of context, and that context is going to be syscall MIPS context. Okay, felf serve, and then we can do this. Okay, 568. Is that what we had? I think it is. Yeah, there's just no way that I got that wrong first try because I'm perfect. And that's good. Oops, fuck my ass. Fuck. 568, here we go. Bam, there it is. Yay, we got it. Yay, what are the odds? So easy. Haha. XD lol. Haha. I don't know what the FSR is. We'll fill in these flags and stuff once we get this working.